Before starting the video, let me make clear that I don't want any controversy or which civilizations made the discoveries first. Instead of claiming someone else's discovery as our own, we should focus on making our own discoveries. If you can't make a discovery of your own, at least accept this fact rather than feeling pride in the discoveries to which you contributed nothing. And stop disturbing or discouraging the people who really contribute to science. I hope you won't make a controversy, but if you are not ready to accept the reality as it is, I suggest that you should leave this video. Let's begin the video. Number sense is not unique to humans. What's unique is to be able to think abstractly about them. Animals need some physical objects to count, but humans can count without any physical objects. Other animals might not know as much mathematics as we do, but research on animal cognition showed the mathematical abilities of other species. In fact, Tunisian desert ants can do both basic arithmetic and geometry. The ant has to find the location of its home against the odds. So the desert ant does something similar to path integration. It can compute how far it has traveled from its home, and it uses the shortest path to return to its home, and they do it by counting their footsteps. How do we know this? By conducting this experiment. Since humans were smarter than other animals, they must have better mathematical abilities than other animals. Australopithecus realized the power of stones. Stone tools extended their physical abilities. Colliding stones together to make stone tools near dry grass created fire. All animals other than humans, except rhinos, fear to get near fire. Fire can burn you if used unwisely, but it gives you great power if you learn to control it wisely. Then people started exchanging their goods. After that, humans developed spoken language. Language changed the way we think about the world. And it's because of language that we stepped beyond simple counting. As human tribes developed, people needed to be precise about everything. In those days, people had competition for resources, and we still have that. They needed to track their resources. For that, they represented one thing with another thing, known as tally sticks. Each stick represents one thing to be counted. This concept is known as one-to-one correspondence. Then someone asked, what if we represent many things with one thing? Great idea. It will solve the problem of handling too many tally sticks. And instead of saying we have sheep and sheep, they said we have two sheeps. Imagine you are a shopkeeper in ancient times. A customer wanna buy 3 sheep but lacks a green diamond. He has one red diamond and one heart-shaped diamond. Other shopkeeper does not consider his demand, but as a critical thinker, you ponder, is this exchange fair? Does one green diamond truly equal one red diamond and one heart-shaped diamond? You analyze the representations and you realize the customer's offer is indeed equivalent. Next, you question, is this exchange principle universal? Can we swap tally sticks representing equal values in other transactions? You consider various scenarios like swapping two heart-shaped diamonds for one red diamond or exchanging one green diamond for three heart-shaped diamonds, and you reach the conclusion that the principle holds. Tally sticks representing equal values can be swapped without affecting the transaction. With this newfound insight, you realize the opportunity and confidently accept the customer's offer. That is, one red diamond and one heart-shaped diamond in place of one green diamond. It works not only for sheep but for everything else. If it works for everything, why not make rules without specifying the object we are talking about? This concept is known as abstraction. So far, we have introduced the concept of addition. The need for subtraction occurs naturally. And since we can count the counting tokens, we needed multiplication. To know exactly how we discovered multiplication, you can pause and read this. Explaining the concept of 1 is very difficult. I mean, try to explain what is 1 to someone who doesn't already understand it, and you will realize how difficult it is to explain the concept of 1. Soon people began making scratches on a bone known as telemark instead of tally sticks. As humans began making clay vessels, they needed good clay, and so clay making was developed. The Ishangu bone shows the sophisticated numerical abilities of early humans. It is the oldest mathematical tool known to humanity. These scratches were made to count things. People noticed that trees grow from seeds and they began farming. Now they did not need to go out and search for food. Now they can grow their own food, which made them settle at a place. Sumerians wanted to keep record of their goods, so they made clay tokens, since clay making was easier for them. To handle clay tokens, they made clay balls known as bulla. They began impressing seals on the clay balls. To remember what's inside the bulla, they impressed the token into it. The tokens made symbols, and now they did not need clay tokens if symbols do the same work. This is one of my favorite pictures. I request teachers not to teach blind obedience to their students. Stop imposing facts on students. Instead, teach them how can they arrive at those facts themselves. Make them feel like they had discovered those facts themselves, which will make them value those facts, and it will create a society based on reason. Also, don't give them useless homework and assignments, because if you do so, students won't have enough time to do any creative or productive work. I never completed my homework or fair copies in school days. At that time, I felt ashamed for not completing fair copies, but I had done many electricity experiments, which made me discover some scientific laws myself. My classmates struggled to understand maths and physics, but I could understand it without much effort because I had real world experience with that. I knew how to solve problems and I could understand what went through the mind of scientists who discovered the laws because I had the same experience. I understood science by first applying science and then I got interested in the science written in the books. One of the many reasons I love science while my other friends hate it is because I did scientific experiments before I even knew that there is a subject like science, and I was nicknamed as scientist in my 4th class. I was not aware at that time, but I was learning science using the Socratic method. Socrates' method involves encouraging students to ask questions and let them find the answers, not by forcing the necessity of finding the answer, but by their own curiosity. Socrates showed the ignorance of authority figures whose conclusions were believed blindly. He showed that just because something is said by elders, parents, teachers, or some authority figures doesn't necessarily mean that it's true. everyone's claims are prone to errors and must be questioned and scrutinized. It doesn't mean to disrespect elders, parents, teachers, or authority figures, but to keep them in check. Let's get back to our topic. People notice these properties in less than or equal to relations and comparing them with equality relation, we find that equality follows the opposite properties, and for addition and multiplication, they find commutative law, associative law, and distributive law. Then people began to use wheels to transport resources. By this time, making symbols to represent goods became popular. To represent different types of goods, different shapes were used, and shapes were limited. So they began making markings on the tokens, which evolved into written language. So the prehistory ends here. Even though I hate doing homework, I am not against writing. Writing is a good thing if not done for a useless purpose. Proofs are really important. To explain why, it requires another video. Writing makes it easier to extend our mind and thoughts outside our brain. Writing helps us recall important facts like the methods which are found by other people and are necessary for doing something specific completely unrelated to your experience. Today we have resources and we are safer in our home unlike our ancestors. So we don't need the wild habits they needed. So stop jumping to conclusions like there is a lion behind the bushes if you hear some noise. How can we leave those wild habits? By suspending our judgments and thinking carefully. By the way, I wanted to make videos on linear algebra and vector calculus, and I have procrastinated for many months or maybe years. And this video is made mostly to familiarize with the foundational ideas of linear algebra. I understood linear algebra from different sources and I want to share my understanding with you.